Algebra II 7.2b, Factor and Simplify Radical Expressions. I really hope you saw 7.2a, and if you haven't seen the previous videos, you can click on this video's description so you can watch them quickly before this one. And the Symmetric Property of Equality says for all numbers a and b, if a equals b, then b equals a. Well, that makes sense, right? Well, we can apply this property to the theorem we learned in the last video, 7.2a. And that theorem said for any non-negative numbers a and b, the kth root of a times the kth root of b is going to equal the kth root of a times b under one radical symbol. We can flip that around, and we get the kth root of a times b in that one radical symbol can be split apart as the kth root of a times the kth root of b under their own symbols. And it shows us how we can factor and simplify radical expressions. So if you have the square root of 20, it's going to equal the square root of 4 times the square root of 5. And that perfect square 4 can be squared as a 2, can't it? So we search 20 for a perfect square factor, 4. And we square the 4 as a 2, and we place it in front of that radical symbol. So 2 times the square root of 5 is the square root of 20, okay? To simplify a radical expression by factoring, we look for factors of the radicand that are perfect kth powers, where k is the index. So when we see a regular radical symbol, there's actually a little invisible 2 there, okay? We just don't write the 2. So we see this, and it's actually, there's a little 2 there, okay? So the square root of 50, we can find a perfect square factor, 25, and do the square root of 25 times 2. That's the square root of 25 times the square root of 2. And the square root of 25 is a 5. We put it in front of the radical symbol, and we get the 5 times the square root of 2, and that's going to equal that square root of 50. See how we did that? So now we have cube roots. We can find a perfect cube factor. If we've got the cube root of 32, that's the cube of 8 times 4, because 8 is a perfect cube factor. It's 2 times 2 times 2, and we can split them apart into their own radical signs. And that 2, that perfect cube factor, 2 times 2 times 2, we can put one of them in front like this and get 2 times the cube root of 4 for the cube root of 32. See? If we've got the fourth root of 80, we find a perfect fourth root factor. We can find it 16 times 5 equals 80. So we can do the fourth root of 16 times 5. We can split them apart using that theorem. And the fourth root of 16 would be a 2. So we get 2 times the fourth root of 5. See? And remember, when we simplify an even kth root, if there's an even number here, we might need to use absolute value in our answer. And we talked about that in the previous video, okay? Remember, there's a link to it in this description if you want to watch that, if you missed it. We've got this polynomial, this trinomial underneath the radical sign. It can be factored as the square root of 2 times x minus 1 squared. That's split apart. We could do the square root of 2 times the square root of x minus 1 squared. And if we take away this square root symbol, the radical sign, and we take away this little 2 exponent, it's going to give us the square root of 2 times x minus 1. It's going to be in absolute value bars because we went from an even root to an odd power. So actually, there should be parentheses around here so you know the whole thing is squared, okay? So any expression that's simplified from an even root, 2, 4, 6, 8, 10, to an odd power, there's actually a little 1 here, isn't there? Needs an absolute value sign. It's kind of a neat rule to follow. Any expression that has a even root here, and we're simplifying it to an odd power, a 1, 3, 5, 7, you're going to need absolute value bars, okay? Unless that expression is known to be a non-negative, okay? But otherwise, we're going to need the absolute value bars. So take a look at this one. So we know there's a little invisible 2 here. For the square root of 300, we can find a perfect square factor of 100 times 3. We do square root of 100 times the square root of 3. The square root of 100 is a 10, so we've got 10 times the square root of 3. Here we're going to do that even root odd power thing here. we've got this trinomial underneath this radical sign. We've got an even root. It's the square root of this trinomial. We can factor it as 3 times x plus 2 squared. That's the square root of 3 times the square root of x plus 2 squared. We can remove this radical sign and that 2 exponent, and we get the square root of 3 x plus 2. And because that's an odd power, a 1, we're going to put the absolute value bars around our x plus 2. We went from an even root to an odd power when we simplified, so we're using absolute value. Take a look at this one. We've got the square root of 16x cubed, and we can break it apart as the square root of 16m squared times m. They can be under their own radical symbol. And we're going to get 4 with the times the absolute value of m times the square root of m. See? If you assume that it's a positive, that it's a non-negative, we could just put 4m times the square root of m. Now we've got the square root of 200, x to the 7th, y to the 8th. This can be broken up into 10 squared times 2. That'll give us our 200. And this x to the 7th could be x cubed to the 2nd power times x. And we can do this y to the 8th as y to the 4th to the 2nd power. See? 3 times 2, we do the product rule for exponents. We multiply them, so that's the x to the 6th. And that little x by itself makes our x to the 7th. See that? And this y to the 4th, and this little 2 exponent makes y to the 8th. We'll remove our perfect square factors, and if you look here, we can remove this radical symbol and these little 2 exponents when we remove it, and we're going to get 10 x cubed y to the 4th, because that's got an odd exponent to it. We're going to put it inside of the absolute value bars, and it's going to be multiplied by the square root of 2x, because that's what was left underneath the radical symbol. See? Take a look at this one. We've got the cube root of 8x to the 4th y to the 5th. We can factor it. This is the largest perfect cube that divides 8x to the 4th y to the 5th. You can multiply it by xy to the 2nd. And when we split it apart into their own radical signs, it's going to look like this. And see, we have x to the 4th, so here's x to the 3rd, and here's that 4th x. We have y to the 5th, so we've got y to the 3rd, and here's 2 more, so that makes that y to the 5th. See how we did that? We're going to remove the perfect cube factor, this 8x to the 3rd, y to the 3rd. See, they're all to the 3rd. And that's going to give us 2xy times the cube root of xy squared. See? We just set all of these to be 3 like that one, so we could remove the radical sign, see? And just make it a 2xy. We have the negative 4th root of 32y to the 9th. We can factor it. The largest 4th power that divides this 32y to the 9th would be 16y to the 8th times 2y. That y to the 8th and that y makes that y to the 9th, see? And we're going to get a negative 4th root 16y to the 8th times the 4th root of 2y. We remove that perfect 4th root factor, and we get a negative 2y squared times the 4th root of 2y. Here's one last one. We've got the square root of 12ab cubed c squared can be split into the square root of 4b squared c squared times 3ab. Put them underneath their own radical symbols. That'll help our eyes a little bit. We'll remove that perfect square factor, this 4b squared c squared. And because this is going to be to the 1st power, we're going to put them inside of absolute value bars. We've got 2 times b times c, 2bc, times 3, the square root of 3ab. See? So we went from an even, because there's an invisible 2 there, isn't there? An even root to an odd exponent, we use the absolute value bars. All right? I know this can be confusing, but if you watched every video, you should have a grasp on what's going on. Our next video is 7.2c. We're going to talk about how to multiply and simplify radical expressions. I'm going to add this video to the Algebra II playlist. And there's going to be links to the Algebra 1 videos on this topic from Algebra 1 Chapter 11 last year, 11.3 and 11.4. I'm also going to put the links to factoring in case you've forgotten how to factor, and any of the Algebra 2 videos from this chapter that are helpful, like that 7.1a, b, c, and the 7.2a that we just did, okay? I know, I keep saying I know it's confusing, but watch these videos, watch this one again, watch the ones from Algebra 1, and just watching these few videos should clear up any confusion you have, okay? Shouldn't be that bad, all right? I hope you're having a great day. I really believe you can do this. And keep your chin up, keep trying. I'm proud of you. I'll see you next video. Bye.